Hello, this is Kiran Kamble, and today I'm going to talk about Chapter 7 Regression Discontinuity Designs from the Shadish, Campbell, and Cook book. So let's start. Regression discontinuity designs are characterized by having a cutoff value from which, like in interrupted time series design, we saw the cutoff point in time. Here is a cutoff value on the assignment variable. Now, it is usually very difficult to implement the theoretical cutoff point in practice, in reality, due to issues with the researchers or treatment administrators, or issues from the participants, or the conditions surrounding the study. So, with treatment administrators and researchers, it may be due to the need or the inclination to assign for participant assignment based on judgment calls and subjective reasons rather than adhering to the strict cutoff value. With participants, it may occur due to slow enrollment of the participants, so trickling in participants, which makes it very difficult for a researcher to manage the study, and so they need to modify the cutoff value. Uh, Also, it can be due to the participants' intent to get into the study, which makes them, put in extra efforts, which will, of course, prove a threat to the pretest validity. Also, the publicity surrounding a study can also, in a way, make it difficult for implementation of a strict cutoff line. So, overriding cutoffs, which we just saw, uh, is it helpful? What harm does it cause? So, such overriding of cutoffs that we discussed violates the basic assumption of a regression continuity discontinuity design and provides biased estimate effects, and is also can be a threat to construct validity. The best solution is to remove these participants cases from the design. If not, these cases should be classified based on the eligibility score than the treatment they received and its effect. For the trickling in participants, it is ideal to uh, create several cutoffs based on entry into the study and deal with these groups as separate R&D designs. So instead of taking that one cutoff point as a when the participants enter, create different cutoff values and then compare all these, considering them as different R&D designs. However, the book strictly says that when there is a falsification of assigning participants or based on spurious data, that can never be rectified. All these other issues can be, but not the issue of falsification. So there are two other issues that the book discusses in terms of R&D regression discontinuity design are crossover and attrition. So let's see what these are briefly. Crossover is a problem when those assigned to treatment do not show up, or those who are assigned to the control group somehow turn up into the treatment group. That is a crossover. Attrition, as we studied in previous chapters, is dropping off of participants after enrollment. Now, this may be due to random reasons or maybe due to the study design or study particulars. So, how does R&D design, that is the regression discontinuity design, RD design, uh, compare with interrupted time series design that we studied in the previous chapter? So the book talks about several similarities between these two designs, the regression discontinuity design and the interrupted time series design. First is, in both cases, the effect occurs at a specific point along the continuum. So for an interrupted time series, it is a specific point in time, whereas for the regression discontinuity design, it is a specific cutoff value over the continuum of the assignment variables. Second similarity is the manifestation of treatment efficacy. In interrupted time series, it is on a time series, after the treatment. So treatment effect starts and then you see the manifestation of the effect. Treatment is administered and manifestation of effect. Whereas on a regression discontinuity, it is a regression line on which after the cutoff value, you usually see the effect of the treatment. Third is threats to validity are similar. These are history and instrumentation. Fourth is regarding complexity of statistical analysis. So both these designs require complex statistical analysis or modeling. So the book has an equation 7.1 pertaining to regression discontinuity design, which is important. So let us discuss that, and it has been shown on the slide at the top bullet point. So in regression discontinuity design, the treatment effects are rarely as significant as those seen in the interrupted time series design. So we saw in the interrupted time series design, there is something called a form of change intercept, where you see a sudden drop or sudden rise after the treatment in the effect. Uh, that is rarely seen in a regression discontinuity design, which then means that we need to apply statistical modeling to tease out the effect. So equation 7.1 uh, is a simpler form of such modeling. It uses analysis of covariance and COA, which is basically assessing the effect of a categorical variable on a continuous dependent variable. It is a blend of ANOVA, analysis of variance, and regression models. So in the equation, if you see, y is the outcome with a subscript I denoting the units in the study 1 to n. Beta hat subscript 0 is the intercept. Z is the categorical treatment variable control with two levels, control and treatment. Beta hat subscript 1 is the treatment regression coefficient. Beta hat 2 is the regression coefficient predicting outcome from the assignment variable, which is x. Xi is the assignment value for a specific study unit, and xc is the assignment variable value for the cutoff point. So xi minus xc is like centering the assignment variable if the cutoff is the mean. This helps assess the treatment effect at the cutoff score, where both groups are supposed to be the most similar. However, the treatment effect can be estimated for any point along the assignment variable continuum by plugging in the specific value for the assignment variable, which can also include the intercept. So xi value can be plugged in based on the point on the continuum of the assignment variable. So that's how that equation is used for statistical modeling. It's a simpler form of the equation. Now, so is this equation all that is required in regression discontinuity design? So as I said, it is a simpler form, and effect estimates derived from this equation can be considered unbiased if the equation is free from two common problems that may occur. One is non-linearity and second is interaction. Let us discuss these briefly. So non-linearity. Simply put, in statistics, it is a situation where there is no direct relationship between the independent and dependent variables, that a change in outcome is not proportional to change in the predictor variable, and this situation is more common in practice. And it requires modifying the x variable in the formula to account for the non-linearity. Now, this modification can be in terms of making it a polynomial variable like x square or x cube. Now, if such change is not incorporated in equation 7.1, if there is nonlinearity, then we will get a biased effect estimation. Non-linearity can also be a problem if the variables are not normally distributed. Hence the importance of descriptive statistics of any variable before modeling. The second aspect is interactions. Problem is interactions. Interactions too are common occurrence and may be the cause of nonlinearity again. As it is important to check the distribution of each variable, so it is important also to check for interactions. In regression discontinuity designs, interactions are common between assignment variable values near the cutoff point and the treatment. So assignment variable values near the cutoff point and treatment usually have interactions. Such interactions will of course give a biased effect estimation, assigning it to treatment wrongfully if interaction is not detected. Hence, it is important to add and then omit interaction terms to diagnose any interaction confounding which will affect the statistical conclusion validity. So you add in interactions and remove the ones which are not significant. So what are the remedies for these two problems that may occur in the modeling? So these two problems that we saw, non-linearity and interactions, are essentially issues are related to modeling function than anything else. It is not to do with study, but rather the modeling. So apart from diligent diagnosis of these issues, there are four solutions suggested by the book that can be undertaken. First is overfit the model with polynomial and interaction terms, dropping those that are insignificant, but keeping those that are on the cusp of significance. The second solution suggested is using standard regression diagnostics and the remedies associated with those. Third is gather additional baseline data on functional form unaffected by treatment, such as pre-treatment data on all variables, and even splitting the sample, if it is large enough, into two groups, and then assigning treatment to one, and then cross-validating later on. But this can be done only with a large sample. The fourth solution is combining regression discontinuity design with a randomized experiment. Let's move to the next point. So, what are the threats to internal validity in this regression discontinuity design? Regression discontinuity design. So, before listing the plausible threats, it is important to note that assessing a threat in regression discontinuity design is relatively easy. Why? Because any condition which is a threat to this design will have to mimic the sudden discontinuity in the regression line at that very specific point of the cutoff value, which is very rare to happen and it can be easily determined. That's why the threats are easy to assess. Now that said, the plausible threats to internal validity for our regression discontinuity designs are history. So if alternate event happened at the same point in of the cutoff value. Second is maturation, which can occur if assignment variable differentially improves between the two groups. It can be detected but would need diligent modeling. Mortality is always a threat as for randomized experiments. A regression artifact, that is a regression to the mean, may occur, but it is again easy to assess and it may cause discontinuity, but it will not cause discontinuity, but rather it will cause a change in the slope, the regression to mean. Selection maturation threat can also occur. In addition to these plausible threats, there are some possible threats which are implausible actually. These are selection, testing, and instrumentation. Next slide. So, can the regression discontinuity design be combined with other designs? So combining regression discontinuity design with randomized experiment is done, and it basically entails using a cutoff interval instead of a single cutoff value. So those values lying above the upper level, so if this is a parallel line, the interval, cutoff interval, those above the score, upper score, are assigned to a condition, maybe control or treatment. And then those below the lower score, lower line, are assigned to the opposite condition. And usually those in between the two lines, that is the cutoff interval, are randomly assigned to either of these conditions. That's basically the gist of what this combination would entail. So main aspect of this combined design is choosing the cutoff score, because there is no specific cutoff point, there is an interval. So choosing that cutoff score to subtract from the assignment variable score is important. So if you remember the equation we saw, in which we, for the regression coefficient of the variable effect on the variable, we choose the computation xi minus xc, where xc is the cutoff value for the assignment variable, whereas xi is the value of the assignment variable anywhere along the continuum. So choosing that xc is what is sometimes problematic in this combined design. Now, Trokim, a researcher, has suggested that using a cutoff value from which all participants are assigned to the treatment, so that point from which all participants are assigned to the treatment, either above or below, R is to be considered as the XC. There is alternative practice in which a median of the cutoff interval is chosen as the cutoff point xc, and this increases the power of the model. But if the interaction hypothesis is rejected, if there is interaction, then the other approach can be used. So you can alternate on the approach based on the data and how the um, model is structured. The book lists 7 different ways in which regression discontinuity and randomized experiment design can be combined. First is all participants on one side of the cutoff are deemed needy and then assigned the treatment, while the remaining ones are assigned randomly to either the control or the treatment group. This is much more ethical design. Second type is the regression discontinuity design could be added to an existing randomized experiment, wherein those who are to be excluded from the study can be added as a regression discontinuity controls. So third type is using several cutoff intervals along the assignment variable continuum instead of just one uh, cutoff interval. This helps in increasing the generalizability of the effect. Fourth type is random assignment of participants to uh, multiple cutoff intervals with a known probability of receiving treatment. Fifth type the book talks about is probability of random assignment within the interval, which can be changed over the site or across sites. Sixth is a randomization interval can be placed at the suspected point of curvilinearity to minimize misspecification of the functional form that we discussed earlier. So that can be done if the specific point is determined. And the seventh type is those within the cutoff interval could be randomly assigned and all others assigned to one condition. So only that particular random assignment within the cutoff interval, rest assigned to one condition. So what are the advantages of this combination of RD design and randomized experiment? There are 3 advantages mentioned in the book. First is randomization increases the power of the power to test the treatment effects. Second is it allows estimation of regression lines for the treatment and control groups over the same assignment scores within the cutoff interval. And third is the problem of setting the cutoff value is eliminated, and as we discussed. So when you have this combination, you have a cutoff interval, so you don't have to go through the trouble of identifying that cutoff value. But of course, in the modeling, you need to determine the cutoff value. The other combination the book talks about is combination between a RD design, a regression discontinuity design, and quasi-experiment. So a quasi-experiment can replace all the randomized experiment in all the types of combinations we discussed a while ago uh, when combining with the regression discontinuity design. Now, such design combination between RD and quasi-experiment would entail resting the decision of assignment of groups at the discretion of the administrator. That's a nutshell. In nutshell, that's what it entails. So basically, the administrator or the researchers have the liberty of assigning uh, the participants to any condition. The design is helpful in a non-equivalent comparison group quasi-experiment by making the option of an exclusion criteria readily available to be used as RD control group. So what we just discussed in the combination of RD design and randomized experiments, the participants who are to be excluded can be included as RD control groups. Another variation uh, can be assigning treatment to control participants in an RD design at the end of the RD study, or run a RD design on a non-equivalent control group. Now, internal validity problem as of dissociating the interventions of interest from the other interventions, that is threats, history threat especially, can be addressed by replicating the analysis around the interventions to show lack of discontinuity, so that this threat of history can thus be addressed. The last point we are going to discuss is uh, about about the power of RD design, regression discontinuity design. So one of the issues that makes RD design less desirable than a randomized experiment is its reduced power due to collinearity between the treatment and assignment variables. So following are some of the methods suggested in the book to increase the power of such RD design, regression discontinuity design. One is placing the cutoff value at the mean of the assignment variable. Second, using continuous assignment variable or a variable with more ordinal categories. Third is avoid correlated treatment and assignment variables. So need to do that correlation assessment before putting them in the model. Fourth is don't overfit non-linear and interaction terms to a model which will take away the degrees of freedom. So it is important to have as many interaction and polynomial terms to account for non-linearity and interaction, but then they shouldn't be overfitted because it will take away the degrees of freedom and affect the statistical conclusion validity. Fifth is assigning those in the middle and those on either side of the cutoff interval to different conditions. So the middle are assigned to one, and on the other side of the cutoff lines to different conditions. This will reduce collinearity. And last solution is to combine regression discontinuity design with randomized experiment. So that is all about regression discontinuity design. Thank you for listening. Until next time. Thank you.